Black holes. What a fascinating phenomenon, right? Scientists and researchers have been obsessed with them for decades, and more recently, thanks to movies like Interstellar and Fantastic Four, even the general public is getting curious about these cosmic phenomena. And that's exactly where I'm taking you today, into space, and more specifically, to a place where not even light can escape, a black hole. Of course, we're gonna need to find a test subject for this, because I myself don't quite have the tech to be able to send myself to space just yet. So what do you say, Gustav, buddy old pal? I'm offering to send you where no human has ever gone before, deep into the heart of our very own Milky Way galaxy. You down? Glad to see you're on board. And of course, I'm supplying the spaceship. And hey, as a bonus, you can even bring Gustine along for the ride with you. All right then, bon voyage to both of you. What Gustav doesn't know, though, is that by heading into the center of the Milky Way, he's flying straight into a supermassive black hole. But what's actually going to happen to our little guinea pig Gustav? Will he manage to fall straight into the black hole unharmed? Or will he be torn apart by the insane gravitational pull of Sagittarius A star? Just a heads up, everything we're talking about here today is very theoretical. There are tons of different hypotheses out there about black holes and how they work, so I really recommend sticking around to the end to find out. But for now, it's time to start today's big topic. Falling into a black hole? What's it like? Our dear Gustav has officially launched his spaceship from Earth, headed straight for the supermassive black hole at the center of the Milky Way, which is a casual 26,000 light years away. Just a quick refresher, 1 light year is the distance light travels through space in a year, which is about 5.8 trillion miles. When humans first went to the moon, that was only about 238,000 miles from Earth. Just regular miles, not light years away. And the farthest any human-made object has traveled is the Voyager 1 probe, which is now about 15.5 billion miles away from the sun. So yeah, Gustav is officially the first human to ever travel this far, theoretically of course. And just to give you an idea of what this means, that's 26,000 light years times 5.8 trillion miles. I'll let you do the math on that one. Now for a little bonus astronomy lesson, Earth is located in a region of the Milky Way called the Orion Arm, so Gustav's got quite the journey ahead. He'll have to pass through all kinds of star systems to reach his destination. Earlier I mentioned something called Sagittarius A star. That's the name of the supermassive black hole smack in the middle of our galaxy. This black hole has a mass equivalent of about 4 million suns. That's right, 4 million solar masses. And honestly, there's still so much mystery surrounding black holes. There are tons of competing theories, but the one that gets talked about the most is general relativity. And that's exactly the theory we're going to explore today with our dear Gustav. Speaking of which, Gustav has just entered the galactic bulge, the massive region of stars and dust that surround the center of our galaxy. See, it's not that scary, Gustav. Now, to make sure this mission goes as smoothly as possible, we're gonna do a little cleanup or alteration. We'll remove all the stars and gas clouds surrounding the black hole so that we get a better view of what's going on. And of course, we're giving Gustav a heat-resistant spacesuit because without that, he'll be toast pretty much instantly. But I won't spoil everything just yet because if Gustav were to find out what's coming, he's likely to just hide in the shuttle and we won't be able to finish today's episode. So here's what you need to know. A black hole is a stellar object that literally bends space and time. Its gravitational pull is so intense that it even bends light towards itself, which is why Sagittarius A star looks kind of like a glowing crescent. Some people say it looks more like Napoleon Bonaparte's hat though, but hey, I guess it depends on how you see it. Anyway, enough talking, it's finally time for Gustav to take the plunge. No. Oh, come on. Alright, I'll give you a little push if you're not gonna do it yourself. There we go, now he's floating out into space, slowly drifting towards the black hole. Don't worry, Gustav, for now, everything's just fine. You're just drifting through space, nothing out of the ordinary. And hey, you're way better off than in that video where you were floating through space without a suit. One thing's for sure though, you're still pretty far from Sagittarius A star, so no need to panic just yet. Gustav might be far away still, but he's already starting to feel the pull of that black hole. Fun fact, any object with strong gravity pulls things into orbit around it, like the ISS, the International Space Station, or the Moon around the Earth, and all the planets spinning around our Sun. And for our dear Gustav, same deal. The gravitational force of the black hole is so intense that our little test subject is now being pulled towards it. Like it or not, Gustav, you're headed its way. He's basically turning into a mini satellite orbiting the black hole. Near Sagittarius A star, the gravitational pull is so extreme that objects orbiting close close to it are able to move at half the speed of light. And when particles collide at those speeds, they generate temperatures of up to 1,000,000,000 degrees. Definitely not cool for Gustave, if you catch my drift. Good thing that I gave him that temperature-regulated spacesuit though. I've got it all planned out. Based on current theories, Gustave is now hurling through space at over 93,000 miles per hour. Just a reminder though, this is all theoretical of course. But speed isn't the only thing changing, and this is where things get really interesting. The area around a black hole, the halo as it's called, warps space and time itself. But hey, you already knew that, right? The first weird effect though? Gustave is about to develop a brand new ability to see something new. He'll be able to see what's happening behind the black hole. Alright, fine, I might be exaggerating a bit. It's not a superpower, it's just that the black hole bends light around itself as it pulls it in. So what exactly is happening to that light? It actually bends around the black hole's halo, creating a surprising mirror or reflection effect. According to some theories, Gustave might even be able to see himself right in front of him, off to each side, left and right, and even behind his own head. Okay, that's in our hypothetical scenario. In reality, Gustave was probably way too tiny compared to the massive black hole to actually spot a reflection of himself like that. But what he can see is the distant stars and galaxies far behind the black hole, bent and warped by its extreme gravity. And it's not just space that gets distorted, but time as well. Let's say Gustine is just chilling in the shuttle, while Gustave's out there struggling near the black hole. From Gustave's perspective, it looks like Gustine is speeding up, moving faster and faster right before his eyes. But this time, distortion doesn't hit all at once. It builds up gradually, getting more intense the closer Gustave drifts to the black hole's point of no return. As Gustave approaches the edge of the black hole, time itself starts to stretch. What feels like a second to him could be minutes for anyone watching from afar. Then seconds turn into hours, then days, and eventually even centuries. If Gustave somehow manages to escape the black hole's pull and get back to the ship that brought him here, Gustine might already be long gone, aka time doesn't work the same in a black hole. And if he returns to Earth after that, the world he once knew could be completely different. Centuries could have passed in what felt like minutes to him. That whole concept is actually explained pretty well in the movie Interstellar, by the way. And spoiler alert, in our version, we're not sending Gustave back to Earth. He's going all the way in. From Gustine's point of view, watching from the ship, she sees Gustave moving slower and slower, like he's stuck in slow motion. Of course, this happens gradually because, as you probably know, everything takes forever in space. In other words, Gustine is now experiencing an entirely different sense of time. So yeah, turns out black holes mess with everyone's perspective, whether you're close up or still far away. Since Gustave sees Gustine and the rest of the universe speeding up, he feels like everything around him is accelerating. The closer he falls to the black hole, the more he notices stellar motion speeding past, comets breaking apart, planets orbiting their stars at wild speeds. In short, the deeper he falls, the more the world he once knew slips away right before his very eyes. But Gustave's eyes are playing tricks on him again, because now he starts to see space around him turn blue. The closer he gets to the galactic monster of the black hole, the more the universe around him seems to shrink into a tiny little bubble. It's like he's being swallowed up by darkness on all sides, while the rest of the universe is just a tiny glowing dot far off in the distance. Honestly, it feels like he's staring through the end of a straw. Meanwhile, back on the ship, Gustine's time perception keeps shifting ever since Gustave started slowing down. If he already looks like he was moving really slowly, now he looks completely frozen. And the deeper this frozen version of Gustave sinks into the black hole, the light coming from his body starts to shift towards the color red. Basically, if Gustine grabbed a telescope right now, she'd see her friend slowly changing color. That's a real thing, by the way. It's called the Doppler effect. So basically, because Gustave is moving farther and farther away from Gustine, there's a shift in the frequency of the waves coming from his body. That's why to his eyes, he looks more and more red as he falls. And in the end, when he seems really far from the ship, he eventually just disappears from Gustine's view completely. And just to be clear, this whole process that I'm explaining takes quite a while. But from Gustave's perspective, that's a whole different story. He's still falling and it's taking forever. He's sinking deeper and deeper into complete darkness, and what little bit of the universe he can still see looks totally insane. As he experiences time moment by moment, second by second, he watches stars explode and galaxies collide. And if he really pays attention, he might even catch planets breaking apart, stars burning out, or even a massive supernova. Yep, if the theory is correct, then time speeds up so much that Gustave is basically watching the end of the universe unfold as he falls. But that's all about to come to a head. Time acceleration reaches an infinite level, a concept that's pretty much impossible for a human brain to fully grasp. Right now, Gustave is standing at the edge of the event horizon. What does that mean exactly? Well, to put it simply, it's kind of like the boundary line between the black hole and the rest of the universe. A sort of invisible frontier that, once crossed, there's no coming back. Not even light can escape from it, just to give you an idea of how intense it is. So far, the only star that's ever gotten close to the black hole Sagittarius A star is S2. It passed at about 1.7 billion miles from the black hole, and even then, it still didn't get sucked in by the galactic monster. Basically, if you cross that line, you're not coming back. What's happening is that the black hole's gravitational force pulls everything nearby towards its center with insane intensity. So yeah, that's why S2 should probably never cross that line, and that's exactly what Gustave just did. Too late, Gustave. That one's on me. I probably should have warned you ahead of time, man. My bad. Scientists estimate that the event horizon of Sagittarius A star is about 8 million miles from its gravitational center. So here's a quick explainer. The singularity is the very center of the black hole, where all of its mass is thought to be concentrated. That's the full 4 million solar masses I mentioned at the start of Gustave's journey. But again, just a reminder, all this is still theoretical. So what exactly is our poor test subject feeling right now? Well, obviously pure terror, but honestly that's not even the biggest problem at the moment. Like I said earlier, the black hole's gravity is so ridiculously powerful that there's no turning back. And it's not looking good for Gustave. It's kind of like being caught in a whirlpool. No matter how hard you try to swim against the current, you don't have enough strength to fight it. According to general relativity, the gravity around a black hole is so intense that everything nearby gets pulled in as soon as it crosses the black hole's theoretical boundary. That's the event horizon, remember? I mean, I think it's still worth repeating. All this is just a theory for now, of course. These stellar objects are so insanely complex, we still don't have the full picture. In other words, no one actually knows what happens once you cross the event horizon. It's a well-developed theory, sure, but it's still just a hypothesis. That said, let's go to the explanation scientists have come up with based on general relativity. So once Gustave crosses the invisible boundary, he starts to feel something very weird happening in his legs, which are closest to the black hole. Basically, his legs begin to stretch, just a little at first. That's because the black hole's gravity pulls harder on what's closest to it. And in Gustave's case, this means his feet and lower legs are feeling it the most. So basically, Gustave feels a stronger pull in his toes than in his head. But for now, he's totally fine. Gustave isn't in pain, and technically, he's not even in danger yet. If this theory is correct, then any astronaut unlucky enough to get this close to a black hole would experience a true nightmare, watching part of their body start to stretch in a way that makes zero sense. Yeah, that's a pretty chilling thought. But honestly, it's way worse for Gustave than for us. Remember how I told you how he's feeling gravity much more intensely in his feet than in his head? Well, it just keeps getting worse. As he falls closer and closer to the center of the black hole, to the singularity, our poor test subject starts to feel like he's being stretched out like a rubber band. What I'm talking about here is the gravitational singularity, basically the center point of the black hole, according to the theory of general relativity. It's sort of the zone where space-time and the gravitational field just go off the rails. They diverge towards infinity. So yeah, according to general relativity, everything that falls into a black hole ends up at this singular point. But let's get back to our pal Gustave, who's currently being stretched out. At first, the feeling is kind of like when you stretch in the morning after waking up. So to start off, not too bad. Gustave just notices that his feet are falling a bit faster than his head, that's all. And fun fact, supermassive black holes, such as Sagittarius A star, actually take longer to produce this stretching effect than smaller black holes do. We don't actually know how far from the singularity of Sagittarius A star this would start happening, but one thing's for certain, Gustave is going through what in general relativity is called spaghettification. Yep, that's the real scientific term. The longer time goes on, the more his feet start stretching, followed by his legs, then his torso, and eventually his entire body, everything that's facing the black hole. Oof, now our poor test subject is really starting to feel the pull. And this whole thing, yeah, it's gonna keep going on for a while. In fact, spaghettification is basically the final stage before death of any object falling into a black hole. It's caused by tidal forces. Those are the stretching forces acting on the outer layers of an object. And just like anything you keep stretching too far, well, you can guess what happens next. At that point, Gustave is going to snap, just like a rubber band that's been stretched too far for too long. Once he gets to around 1 million miles from the black hole's singularity, at least according to theoretical estimates for Sagittarius A star, he'll be so stretched out that he literally gets torn in two. But it doesn't stop there. Our poor Gustave might even stay conscious for a few more seconds. Yep, because being split in half doesn't necessarily mean any vital organs have been hit yet. So brace yourself, Gustave, it's not over yet. See, even though Gustave's fate is sealed, being ripped in two is just the beginning. The tidal forces from the black hole will keep ramping up the spaghettification, stretching and tearing him even more as he's pulled closer to the singularity. In other words, he's just gonna continue getting shredded up. So yeah, to put it simply, we'll end up with several little pieces of Gustave. And the longer time passes, the more those pieces keep stretching out until they're as thin as a line of atoms. His atoms eventually merge into the singularity of the black hole, like a speck of dirt squished onto the tip of a pin, more or less. In the end, Gustave disappears entirely into the heart of Sagittarius A star, leaving no trace of his journey through space. The cleanest, most discreet death imaginable. Our dear Gustave has just gone through every possible state of matter in the name of science. I think he deserves a round of applause for that. But hey, let's not forget, there's a chance that none of this would happen like this at all. Honestly, it all sounds kinda crazy, and for a good reason. This is still very much a big old theory based on general relativity, just to remind you. But hold up, that doesn't mean everything I just told you was a lie. A black hole really is a spatial anomaly, which is exactly what makes it such a paradox, actually. Some aspects seem downright unreal, like the idea of infinite time dilation. Even though plenty of scientists support the theory of the black hole's singularity, none of it is certain yet. Of course, we're still studying the phenomenon from Earth, but black holes are so far away that there's no way we can get close enough to fully understand them. So in the meantime, we're just exploring different ideas. In fact, some experts believe a black hole might actually be a gateway to another universe, or maybe even a kind of teleportation tunnel, like a wormhole. So yeah, in the end, we really don't know what happens once you cross the event horizon. Honestly, if I'd been a little nicer, Gustave probably could have made it out alive. But hey, let's bring him back anyway, because let's be honest, I'm definitely gonna need him again soon. There you go. Happy now, Gustave? Oh, come on, you literally pushed the boundaries of science with your sacrifice. And don't tell me you didn't think it was kind of cool to turn into a string of atoms. All right, I won't push it, but seriously, thanks for your bravery, buddy. Still, it kind of leaves us hanging, doesn't it? With all these theories, all the advances in science, all the astronomical discoveries, who knows? What do you think could really happen if someone fell into a black hole?